Hi everyone, this is Vlad from TechVA, and in this video I want to show you our image recognition part of Junior. How you can make manual requests, how can you make automated requests, how can you parse data, filter it, and extract it to object space so you can do your quick slap comms in minutes rather than hours. And in the beginning of this video I put it a short Junior show reel. What system can do for you today automatically. I hope you will enjoy it. Thank you.
I see screens of green, red markers too. I see the key flickering for you, and I think to myself, what the hell do I do? I see still that's blue and halos of white. The CG's too dark, the plate is too bright, and I think to myself, what the hell do I do? The color of the display is changing way too much. The way the patch is drifting isn't helping us as such. I see shots get approved, but I just get notes. What I want to do is get my codes. I hear compass cry, I watch the shock as they are staying past 12 o'clock, and I think to myself.
I hope you enjoyed the Junior show reel and the music. Now I want to show you how you can make a request. So let's take a look at this. Is just I just put some frame ranges to limit it for these demo purposes. So first of all, we have our asset system, which allows us to store all necessary data in one place attached to the plate. I'm offering here to use TCL expressions, so you can specify your path in your pipelines where you want to store the information after the result. And then proxy done, so means that the system requires some proxy, and this is also automated process. To make a request, you just bring a marker tool, which is responsible for any sort of request for image analysis. You connect to asset, so you will store the results, and we'll be looking for any objects here. Like you can always find something like whatever you want and make selections. We'll be looking for all of the objects here, and the system is kind of working out of the box. You just click get markers, request it, and this is it. It's in progress. Our speed of analysis is something like around one frame per 1 or 2 seconds on 2080 Ti with 12 gigabytes of video RAM, but on higher GPUs and with new architectures it will be even faster. So you can always see the feedback when the system is generating some labels. You can see the progress, and you always will receive the results of analysis statistics back into this area, so you understand what amount of objects you have, total amount of objects, existence of any object in the frame, and the statistics on the time. And so let's just click another button, and that's pretty much it. After analysis is done and we received our results, including statistics, for example, for these 101 frames, it took 163 seconds to generate masks for us. And then we can just create our data parser, just clicking here, create data parser, and then click button parse, and it will extract information for us from the results of analysis. We have all the masks here, some of them flickering, some of them not. Each of this object is the individual object with its own qualities, like mask, sort of tracking, and size of the bounding box. That allows us to make certain things. For example, first of all, you can control all of this, like fonts and ways of data visualization. in this case, what the colors of the labels represents is the confidence of the system in the detection. And to actually review that, you can go into this sort of spreadsheet approach and workflow and find here you go, and find some information here of whatever you're looking for. But you can also, I mean, what system can detect in the video, but it also represents you with all these labels information, so you can review results of analysis in more or less not jumping or static kind of area. But you always can pre-mod them, even like just to see all of this like objects, what they are in the shot. You also can do filters here. Let me show you how it works. So in our options here, we can filter by name, for example, person or boat, whatever. Like you can do both person and whatever, the rest will be filtered out from the results. But you also can filter it by length of the track. So you can find which tracks has actually the full frame length and which objects and what might potentially require your attention, or level of confidence. So the level of confidence, this labels starting from red is bad, blue is kind of 50-50 confidence, and green is going to close to 100% confidence on that this object is this object, sort of, yeah. Another filter you can use is the filter on area, which allow us to kind of like be more specific with selections, and even like finding, for example, only centers which are intersecting with this area, or even like maybe finding even like any sort of bounding boxes intersecting with it, or making an inverted approach. So like just to quickly to get to something what you're looking for. But on top of that, we also can open the full settings of each of these objects which we have and their status. It's showing all active objects for you. You can invert and hide and kind of do all these quick operations. And it also brings you statistics, the label name, the this is kind of the size, this is the frame range, this is the length, and this is the confidence level of the prediction. It also can help you with, for example, not only like boats, but for example, we're looking at the markers, and we need to find some information on markers, and let's just go into the area. So, for example, you're dealing with some tracking things, so you need to find some. This example of model, of our detection model, it has one naming convention, only markers, so you can see it here. But you also can use multi-naming convention and be really specific to do easier clusterization of data. But for example, you need to find among all markers and you don't have time to retune system and marker model works well, you can turn on filters and filter it by specific areas and extract this information, whatever you need to get. And just whilst we're talking about tracking and trackers, you also can extract tracking data from this analysis, and you can see all your tracking information here. But I will cover it in the other videos. Let's move back to image recognition part. So now we know that we can filter objects, we can find them, we can do whatever we need to kind of in terms of search and filtering. And then what you can also do is to go to the object space, and I'll show you just how to kind of like extract all of this, how it all works and as a buttons. And I'll move on to another shot with the cars from the junior showreel. So you need to click export destination. It will create you this set. What this set means for us. Let's go here deeper. This is the area where you can put whatever you need, so we can duplicate it later and put it into each setup. You can even, like, for example, here I'm using edge extend to like obvious kind of fix issues with some edges, at least to attempt it, to try to apply it to all. You can just link this, and that means that this thing will go into the new setup. The new setup, after we click this button, created from list of this data, and then you can just click extract from parser, and what it does is it basically takes everything what's inside the group, what's been filtered out here. You can bring it as this sort of setup. What we have here, we have a few options. Let me just close the rest of the things. So option here, it's kind of like by default it brings you to the object space workflow, but here you can turn on and off anything what's dependent and being created. You can manipulate labels and reformats, enable backgrounds, but what I want to show you is one of our statistical tools. It's not necessary we'll work on all the things, because what it does, it just calculates kind of like doing segmentation, clusterization based on the size of the bounding boxes. And here it's not really distinctive perspective, but if you have your crowd setups and things, you can quite easy split it. But you also can easy move objects from one place to another. For example, we want to move this person to the foreground, and we'll have one person red here. So that's how easy it is manipulate. You can even like duplicate them and have them in both channels. All what it does, it just connects this for you, calculates and connects all of these objects. Also, we can then control our foreground, midground, holdout setup here. It's kind of simple and basic for now, but it's good enough to produce us kind of some results. We also getting here to the object space. That's what I want to show you, what it's kind of like means in this case. The object space kind of like representing the object. It's not zoom. It's not like we're not changing image. We're working with integers here, and that's why all transformations, whatever happens in impulse, and we basically just doing cropping to the area. So here is our image is in 1:1. It's only like crop area is moving, and that allows us to do any sort of manipulations. Like for example, you want to bring all of these objects to fix edges, and do whatever you kind of like think you need to do with this, but all at once. Easy. If you want to change individual things, you could just break expression and adjust individual values. That's pretty much it about the data parser functionality. And I'll be moving on to the shot from the demo reel with the cars, and I'll show you how you can move and what you can do in object space manipulation. But before that, I also want to show you how to do manual requests, because that's another functionality of TechVA Junior. You can get masks pretty much for anything, and for that we built the system which allows you quickly make your requests, as quick as like creating either just the one dot in your Bezier curve and then specify which area you want to mask. Same I did with the water. It's literally just 2 keyframes. Everything done to minimize clicks. So the system, if you have some frame ranges only here, the system will analyze and return results only for this frame range. So kind of like done for optimization purposes. And also, like, you can, for example, like flag is hard to catch like objects and things. You can just literally put a few keyframes here, click mask generate. As you can see, for those 3 objects, it took 123 seconds, 401 frames to generate us those holdouts. I recommend to follow proper naming convention because our data parser also has this little checkbox which specify this information good for train. If you're happy with the results, your labels will go to new detection dataset. Then you can process it easier. So it's kind of like moving us to the idea of label or train whilst you work workflows. That's pretty much about the custom requests and the filter data, and we're moving on to the compositing part of object space on the car sequence. After analysis is done, we can move on to the Nuke script. So here I'll explain you everything. Let me just show you the shot. So that's kind of like a temp version of the shot. How can we get here, and how long does it take for us to put, for example, this sort of car ID layout? So we have our plate from which we did the analysis to get all this information about masks from our data parser, and this is our generated masks. And then we created the object space, right? We went to the object space, and that's simple. So, for example, we have this car. We have this car here. It's in its own kind of space and its own things. And we have the mask, but we're missing the shadow. So first, what I just doing like here is just bringing some shadow back. And it's simple as well because we already have the mask of the car. We can just kind of shrink it, put it down, and specify our area to whatever we want to extract, and then max back alpha channel. So as fast as we can to get to this. So analysis result was done in, oh no, hang on a second, I need to get here. So it's done in 118 seconds for 125 frames, because we only have 3 objects here. More objects, it will take less time, longer time, sorry. So object space, so we can do pretty much anything with those objects. Let's take a look at the shot. So this is our kind of like real-time processing. I'll be turning off the right car, and I'll be turning off this guy. So this is our initial stage. That's what we have as a shot. Our creative challenge and task can be here, like by adding some car, racing car, whatever, like some drama here happens here. So let's put transform to D. Jesus Christ. Okay. Shift T. Here you go. So I just wanted to have center here in the area, and then we can just put it to the ground, kind of like where our ground is represents. That's it. And we can move on to the full kind of like view of the shot. And now we can start like researching our ideas, what we can do. Let's change it, actually, for the example purpose, let's change the color with 2 more red. Not pink, but whatever, weirdly red. Here you go. So as you can see, there is like jitters and everything happens, obviously, but at the same time, like to discover your ideas and like maybe making a quick slab comps, we're talking about minutes rather than hours of work before you even like can make a decision. Do you need to film something, or you need to bring some extra information or material? This is just a simple offset, but we also can just do an extra animation for that. So let's just take, instead of like moving it here, let's just go back to he actually was a good frame. Let's move him, this guy, somewhere behind this car, somewhere like really, really far away there. And we will be kind of like mimicking the overtake. So it's kind of like we'll be accelerating from this angle. Like angles are more or less okay for this idea. So we'll just put a few keyframes here and here, and we'll just move. Sorry, I said move, not scale. Move our object somewhere to acceleration, and scaling it, it's actually quite far. I mean, let's just move it somewhere here, so it can just, yeah, here you go. So it's kind of like can work. And now we can quickly iterate our idea. So it's less about like lots of preparations for like something what we need to make it a principal decision or do something else. There is obviously certain limitations on jitterings and other things, but at the same time, that's kind of like, I wouldn't say like it's too jittery to discover the idea. And also because we can use custom objects, custom data, so we can kind of attach to any sort of objects. Here, for example, I don't have this in the data set. I just made this kind of like area of interest to get that. So I can reutilize this information and bring it like, for example, a bird. Let's just turn off this other car I have here. I'll just turn this off, and this is going to be our seagull. And our seagull will be attached. So let me just do it like this. Tick. Here you go. It will be attached to this area, so it will just stay in those coordinates, and you can do something else on this. I mean, seagull is just an example of like attaching to that. As you've seen in the demo reel, you can quickly mock up your idea of what needs to be in a shot, make principal decisions, use all these draft masks, and whilst you either using other algorithms preparing the final image segmentation masks, or you just going in a traditional way of like requesting information, requesting work from rot prep vendors. That's pretty much it about all of these ideas and about TechVE Junior and especially Object Space. We are in closed beta, and if you're interested in testing our technology in your workflows and pipelines, please go to our website and click button Get Started. We'll get in touch with you and organize a call. Leave routine to machines.